So let's take a look at the workflow you're going to use over the course of Intro to Computer Science CIST 1400. We use about 5 different tools, all told. To use a terminal, such as PuTTY, or such as the built-in terminal on your Mac, to connect to Loki, which is a Unix server, on which we'll use Vim to write our Java source code. Vim is just a text editor. Then we'll turn that into a class file using the Java compiler. And once we're done with that, we'll use the Java virtual machine itself in order to run this file. So PuTTY, all that is a program that we might use to connect to Loki using a secure shell connection. All a secure shell does is let you connect 2 computers together over typically the internet. Loki is the name of our server. You're probably going to do most of the work in class while connected to Loki on the server. This means that you don't have to worry at all about having Java installed on your own computer. Vim is an industry standard text editor designed for maximum efficiency and was specifically designed so that you never have to use your mouse. Vim has existed. Vi, on which Vim was based, was released in somewhere in the 1970s, and Vim is older, frankly, than most of you. But it's powerful, it's also archaic, and it's a little bit clunky, but we'll get there. We'll definitely get there. We're going to use Vim to edit source code. Now, Java is the programming language we'll be using, and so in order to use that, we'll have to use the Java compiler to turn our source code, which is plain text in which we write in Vim, into machine code, which we saw earlier and which is almost incomprehensible for us. And then we'll run that machine code with the Java virtual machine. So let me show you, real briefly, what this looks like. So this is my PuTTY window. I'm just going to connect to Loki, get the screen to where it needs to be. You'll note that my password doesn't echo to the screen. This way no one is able to look over your shoulder and tell how many characters are in your password. So from here, we're going to move into the samples folder. We'll see what's in there. We'll move into Unit 1, so that's where we are right now. We'll make a directory called Day01. And we'll move into that using the cd command. And now that we're here, we're going to use Vim, which we open just by typing Vim, hello world.java. The .java indicates that this is a source code file named hello world, which we're going to open with Vim. Now this is the sort of the industry standard first program that you write in any programming language. It was first done in the Intro to C book by Dennis Ritchie, among others, who's one of the authors of the C programming language. So with Vim, right now I'm in command mode. I hit I, I'm in insert mode. We'll start with public class hello world. That has to match our file name exactly, and we'll get there in a second. Public static void main string args. This will be explained in a little bit more detail later. For now, the thing that you need to know is that when we run a Java program, the first thing that the Java virtual machine will do is look for the main method, which we indicate by having the word main here. And then once it finds it, it does the stuff in there. And we'll be able to write our own methods later, but for now we'll just do the main method. Go system.out.println. This is going to print to the screen using the system.out stream. Hello world. And we put a semicolon at the end of this line. We'll close our curly brace. We'll close our second curly brace. We hit escape to get back into command mode. And then we'll write and quit using :WQ. Or if you want to, you can be faster and just use :X. So now, when we list all the files that are in this folder using the ls command, we'll see this hello world.java. But we can't run it just yet. We need to compile it. So when we compile it, we'll type javac hello world.java. What that'll do is that'll look at our source code. It'll tell us if there are any errors, and if there aren't any errors, it'll create a class file. And we'll know that there aren't any errors because it won't tell us anything after we're done. So we see here that we don't get any messages, but when we look again, we can see that hello world.class, which means now we can run our program. And when we run this, it's just going to print the phrase hello world to the screen. So we'll clear the screen, and when we clear the screen, all that does is just move stuff up. If we scroll up using the scroll bar, we can still see everything. We'll type Java, which runs our Java program, hello world. Now if I want to, especially if there's only one class file in a folder or in a directory, I can just type the first letter and then hit Tab, and the command line will fill out the rest for me, which saves you a little bit of typing. Now as soon as we hit Enter, what we're going to see is the phrase hello world printed to the screen, and then we're right back to the command line. Now this is kind of cool. It might not, this particular program isn't exactly powerful. It only does one thing. But the cool thing is that it does exactly what we tell it to. Now, we can open up our hello world.java file again, and the way that I flipped through those real fast is by hitting the up arrow. And if we wanted to, we could add on a little bit more. Nice to see you, for example. We can save and quit. We compile. If we don't compile, our changes don't get carried over. Compiling is how we make sure it has the latest version. Everything's still good. Java hello world, and now it says hello world. Nice to see you. If only all software were this friendly. So this is what your workflow generally looks like. We'll use the command line to navigate around. We'll use Vim to create source code. We'll use the Java compiler, which we access with Java-C, like you see here, it stands for Java compiler, to turn our source code into machine code, and then we'll run our program using the Java command. And when we run our program, we get some output, ostensibly. Now this is probably the simplest program we'll do this semester. As the semester progresses, we'll use structures like if statements and switches and loops to write some software that, even though it's built from very simple parts, ends up being remarkably complex. Alright, we're going to take a break here, and when we come back, we'll finish out the rest of this.